Right now, the spacecraft launched during the Ford administration is sitting more than 15 billion miles from Earth, and it's still talking to us. In just a few months, on November 18, 2026, it will cross a distance so extreme that a radio signal traveling at the speed of light needs a full 24 hours just to reach it.
That spacecraft is Voyager 1, and the number itself is worth sitting with for a moment. 15 billion miles was already true late last year.
By the time you're watching this, it's already pushed past 16 billion. Closing in on a distance NASA calls one light day, a threshold no human-made object has ever crossed before. One light day is the distance light itself travels in 24 hours, roughly 16 billion miles, and it's not a symbolic round number.
It's a communications fact. Send Voyager 1 a command at that distance, and it takes a full day just to arrive.
If the spacecraft answers immediately, the reply takes another full day to get back to Earth. A simple back-and-forth conversation, the kind that used to take seconds during Voyager's Jupiter flyby in 1979, now takes 2 full days from a spacecraft still faithfully checking in.
Nothing else humanity has ever built is far enough away for that sentence to even make sense. Voyager 1 launched from Kennedy Space Center on September 5, 1977, on a mission originally built to last 5 years and visit 2 planets.
It flew past Jupiter in 1979, discovering a thin ring around the planet and 2 previously unknown moons, Thebe and Midas. It reached Saturn in 1980, adding 5 new moons and a newly identified ring called the G ring, to what astronomers knew about the solar system's most photographed planet.
That Saturn flyby set Voyager 1's final trajectory, sending it up and out of the plane in which the planets orbit the Sun. It has not needed a course correction since.
For nearly 46 years, it has been coasting on that same heading at the same roughly 38,000 miles per hour. An object still governed almost entirely by the physics of a single push delivered decades ago. Voyager 1 wasn't built alone. It launched roughly 2 weeks after its twin, Voyager 2, both timed to take advantage of a planetary alignment that happens only once every 176 years, when Jupiter, Saturn, Uranus, and Neptune line up in a way that lets a spacecraft use each planet's gravity to slingshot toward the next one, saving enormous amounts of fuel it would otherwise need to carry. Engineers called it the Grand Tour, and missing that particular alignment would have meant waiting nearly 2 centuries for another chance to visit all 4 outer planets in a single mission. Only Voyager 2 ended up visiting all 4 outer planets. Voyager 1 was deliberately sent on a faster, more direct path, specifically to fly close by Saturn's largest moon, Titan, a scientific priority, important enough that NASA was willing to sacrifice any chance of continuing on to Uranus and Neptune afterward. That single trade-off, prioritizing one moon over 2 more planets, is the reason Voyager 1's trajectory went upward and out of the solar system's plane after 1980, setting the exact path that, decades later, would carry it toward interstellar space first. That trade-off paid off scientifically almost immediately. When Voyager 1 flew past Titan in November 1980, its cameras found not the icy, cratered surface scientists half expected, but a moon completely wrapped in thick orange haze, its surface entirely hidden beneath a nitrogen-rich atmosphere, denser than Earth's own. That single discovery reshaped Titan from an obscure moon into one of the solar system's most tantalizing targets, eventually justifying an entirely separate mission, the Cassini-Huygens probe, which parachuted a lander through that same haze onto Titan's surface more than 2 decades later. NASA's decision to sacrifice a Uranus and Neptune flyby in exchange for that one close pass is easy to defend in hindsight. But at the time, it was a real bet, made with full knowledge that Voyager 2 alone would have to cover the outer planets Voyager 1 was giving up. It's worth remembering that trade-off every time Voyager 1's current distance record comes up, because the very path that made that record possible was chosen specifically to prioritize scientific curiosity about one moon over the completeness of a planetary tour. Understanding what Voyager 1 actually crossed in 2012 requires picturing the heliosphere as more than a single wall. What makes Voyager 1 historically unique isn't the flybys from the 1970s and 80s. It's what happened after NASA had already declared the primary mission complete. On August 25, 2012, Voyager 1 became the first spacecraft in history to cross the heliopause, the boundary where the Sun's influence effectively ends and true interstellar space begins.
Picture the Sun as blowing a bubble of charged particles in a magnetic field around the entire solar system, a region called the heliosphere. The heliopause is the outer skin of that bubble, the place where the pressure of the solar wind streaming outward finally gets matched and overwhelmed by the pressure of the material drifting between stars. Press next and enter an audio prompt and see how I sound. In the Sun's neighborhood. In any meaningful physical sense. You're in the galaxy
Press next and enter an audio prompt. That skin isn't a single sharp line either. The solar wind, the constant stream of charged particles the Sun throws outward in every direction, travels faster than sound speed in the surrounding plasma, until it suddenly can't anymore, slamming into resistance from the interstellar medium and abruptly slowing down. That sudden slowdown is called the termination shock, and Voyager 1 crossed it in December 2004, roughly 8 billion miles from the Sun. Beyond the termination shock lies the heliosphere, turbulent, compressed transition zone where solar wind particles pile up and swirl before finally giving way entirely to interstellar material. The heliopause is the outer edge of that transition zone, the true boundary, and it took Voyager 1 nearly 8 more years of travel after the termination shock to actually reach it. Confirming that Voyager 1 had actually made it across the heliopause in 2012 wasn't as simple as flipping a switch and seeing a number change.
Spacecraft's broken plasma sensor meant scientists had no direct density reading to point to in the moment. Only the indirect plasma wave measurements that required an actual solar event to trigger a detectable oscillation. Different instruments on board told slightly different stories about what Voyager 1 was flying through, and researchers spent close to a year debating exactly when the true crossing had happened before NASA felt confident enough to officially announce in September 2013 that Voyager 1 entered an audio prompt and see how I sound.
That delay wasn't a failure of the mission. It was a reminder that a boundary nobody had ever measured directly doesn't come with a clearly marked sign, and scientists would rather take a year confirming a historic first than rush an announcement they might later need to retract. Even the language used to describe the milestone stayed cautious for months afterward, with researchers preferring phrases like very likely, consistently, interstellar space over any flat, unqualified declaration, right up until enough independent instrument readings finally lined up to remove reasonable doubt. Voyager 2 eventually made the same crossing on its own, slower path, reaching interstellar space in November 2018, 6 years after its creation. That gave researchers something Voyager 1 alone. Voyager 1 alone never could. A second data point taken from a completely different direction, at a different point in the Sun's roughly 11-year activity cycle. The comparison revealed the heliosphere isn't a symmetrical bubble at all.
Conditions. Voyager 2, measured at its own crossing point, didn't match what Voyager 1 had found 6 years earlier in a different direction. Evidence that the boundary bulges, compresses, and behaves differently depending on where you measure it, shaped differently by the changing pressure of the Sun's own activity and by whatever the interstellar medium happens to be doing on that particular side of the solar system at that particular time. Nobody who designed Voyager 1 expected it to still be operating when that moment came.
The mission was built for 5 years, quietly extended to 10, then to 20, and now sits at nearly 50. Marav Ofer, an astronomer at Boston University who leads a research center revisiting Voyager's data to better understand the heliosphere, has said plainly that nobody ever expected the Voyagers to actually reach and cross the interstellar medium.
And yet, Voyager 1 didn't just cross that boundary. It kept transmitting data back across it, turning what was meant to be a 2-planet tour into humanity's only direct sensor sitting outside the Sun's protective bubble.
The first surprise waiting on the other side had nothing to do with what scientists expected to find, and everything to do with a broken instrument built decades earlier. Voyager 1's dedicated plasma sensor, an instrument designed to directly measure the density of charged particles around it, stopped working shortly after the Saturn flyby in 1980. That left engineers with a workaround. Using the spacecraft's plasma wave instrument to listen for oscillations triggered whenever a burst of solar activity, like a coronal mass ejection, rippled outward and rattled the plasma around Voyager 1. Those oscillations reveal plasma density indirectly, the way you can estimate the depth of a well by timing how long it takes an echo to return. Using that method, scientists discovered that the plasma outside the heliopause is roughly 40 times denser than the plasma inside it, a jump sharp enough to work as a boundary marker in its own right, confirming Voyager 1 really had left the Sun's bubble behind. The boundary itself turned out to be far stranger than a simple line on a diagram, as Voyager 1's instruments recorded conditions right at the edge of the heliopause picked up something that sounds almost contradictory. Extremely high temperatures, in the tens of thousands of degrees, in a region so thin and sparse that the spacecraft experienced nothing like heat in any conventional sense. Individual charged particles there move incredibly fast, which is what temperature technically measures. But there are so few of them, spread across such enormous volumes of space, that there isn't nearly enough material to transfer that energy the way a flame would on Earth. It's less a wall of fire and more a wall of speed. Ferociously fast particles too sparse to burn anything, including the spacecraft flying straight through them.
More recent analysis of the region has added another wrinkle. Voyager 1 detected magnetic field lines at the boundary that appeared stronger and more tightly organized than earlier models predicted, suggesting the interstellar magnetic field beyond the solar system may be pressing against the heliosphere with more force than scientists had assumed. That matters because the heliopause isn't a fixed, static shell. It behaves more like a balloon under uneven pressure, pushed and reshaped by the competing forces of the Sun's own outward wind and the interstellar magnetic field bearing in from outside. Understanding exactly how hard that outside pressure pushes helps researchers model the actual shape of the bubble protecting our entire solar system.
How are you today?
Not just at the point where Voyager 1 happened to cross it,
next and
but
enter
around
an
its
audio
whole perimeter
prompt
and see how
None
I
of that
sound.
boundary is silent either.
How are you today?
In
Are you ready to
2021,
create with
researchers
CapCut?
led by Stella
Press next and enter
Author
audio
Cornell
prompt and see how I
University
sound.
published
Hey,
findings
how are you today?
based on years
Are
of
you ready to
Voyager
create
1's
with
plasma
CapCut?
wave data.
Press next.
Describing
Hey,
a
how are you
faint,
today?
continuous
Are you
hum
ready to create with
detected in
CapCut?
interstellar space.
Press next.
A
Hey,
persistent
how are you
low-level
today? Are you
oscillation
ready
in
to
the
create with
plasma
CapCut?
that never fully
Press
goes
next.
quiet,
Hey, how are you
even in
today?
the absence
Are
of a
you ready to
solar
create
storm
with
rattling the
CapCut?
region.
Hey, how are you
Before
today?
that discovery,
Are you ready to create with
scientists
CapCut?
had only been able
Press
to
next
detect
and
plasma
enter an
density
audio
during
prompt and see how I
discrete,
sound.
dramatic events,
Hey, how
like
are you
flares
today?
from the
Are
sun
you ready to
reaching
create
all the
with
way
CapCut?
out to Voyager 1's
Press next
position.
and enter an audio
This was
prompt
different.
and see how I
A
sound.
constant
Hey,
background
how are you
signal,
today?
evidence
Are you
that
ready to create
interstellar
with
space
CapCut?
isn't the dead
Press
calm
next.
many
Hey,
people
how are you
picture when
today?
they hear the
Are you ready to
phrase
create with
empty
CapCut?
space.
Press next.
But a
Hey,
low,
how are you
continuous
today?
hum of
Are you ready to
activity,
create with CapCut?
always present, just
Press next.
usually
Hey,
too faint
how
to
are you
notice.
today? Are you ready to create
Inside
with
the Deep
CapCut?
Space Network's
Hey,
control
how are
rooms,
you today?
the
Are you
countdown
ready
to
to
that
create
light
with
day
CapCut?
threshold is more than
Press
a
next
symbolic
and enter
date.
an audio
Circle
prompt
on a
and see
calendar.
how I sound.
Every added
Hey,
light
how
second
are you
of
today?
distance
Are you ready
stretches
to
out the
create with
round-trip
CapCut?
conversation
Press
between
next
Earth
and enter
and
an audio
Voyager
prompt
1
and see how I sound. Hey, how are you today?
But wait,
Are you
a
ready
little
to create
further,
with CapCut?
and mission planners have to
Press
build
next.
that growing
Hey, how are
delay
you
directly
today?
into
Are you
how
ready
they
to create
schedule
with CapCut?
commands, plan
Press
instrument
next. Hey,
shutdowns,
how are
and
you today?
diagnose
Are
problems.
you ready to create with
A
CapCut?
troubleshooting exchange
Press
that
next.
might
Hey,
have
how are you
taken an
today?
afternoon
Are you
back
ready
when
to create
Voyager
with
1 was
CapCut?
passing Jupiter
Hey, how are
now
you
takes
today?
the better
Are
part
you
of
ready
a
to
week,
create with
since each
CapCut?
attempted fix
Press
requires
next and
sending
enter
a
an
audio
audio
prompt and
waiting
see
a
how
full
I
day for
sound.
it to arrive.
Hey, waiting
how are you
another day
today?
for
Are
confirmation.
you ready to create with CapCut?
It worked, and
Press
often
next
repeating
and
that
enter an
cycle
audio
2 or
prompt
3
and see how I
times before
sound.
an issue is
Hey,
fully
how
resolved.
are you today? Are you ready
Crossing
to
one
create
light
with
day
CapCut?
doesn't change that
Press
process
next.
overnight.
Hey, how are you today?
But it
Are
does
you ready
mark
to
the
create with
moment the
CapCut?
delay itself becomes
Press
an
next. Hey,
entire
how are
day
you
in each
today?
direction.
Are you ready to create with
A
CapCut?
round-trip conversation
Press
stretched to
next.
a
Hey,
full
how are you
48
today?
hours
Are you ready
minimum,
to create with
longer
CapCut?
than it takes for many
Hey,
news
how are you
cycles to
today?
run their
Are you
course
ready to
back on
create with
Earth.
CapCut?
That kind
Press
of patience
next and
has
enter an
effectively
audio
become
prompt
the
and see how I
defining
sound.
skill required to
Hey,
keep
how
this
are you
mission
today?
alive.
Are you ready to
More
create
than
with
any
CapCut?
single piece of engineering
Press
cleverness.
next. Hey, how are you
Every
today?
fix
Are you
described
ready
so
to create
far,
with CapCut?
the dormant thrusters
Press
revived
next.
in
Hey, how are you
2017,
today? Are you ready
the
to
corrupted
create with
chip
CapCut?
rerouted in
Press next. Hey,
2024,
how are you today?
instruments
Are
shut
you ready to
down one
create
by
with
one to
CapCut?
stretch a
Hey,
fixed and
how are you
shrinking
today?
power
Are
budget.
you ready to create with
Shares
CapCut?
the same underlying
Press
constraint.
next and enter an audio
Nothing can be
prompt and see
rushed,
how I sound.
verified quickly,
Hey,
or
how are you
corrected on the
today?
spot.
Are you ready to create with
A
CapCut?
team accustomed to
Press
same-day
next and
answers
enter
in
an
almost
audio
every
prompt
other
and
part
see
of
how I
modern
sound.
life has
Hey,
spent
how are you
decades
today?
solving
Are you ready
problems
to
on a
create with
communication
CapCut?
schedule
Press
better
next.
suited
Hey,
to
how are you
exchanging
today?
letters than
Are you
running
ready
a
to create with
spacecraft.
CapCut?
And that discipline
Press
is
next.
precisely
Hey,
what
how are
has
you
kept a
today?
computer
Are you
built
ready
in
to
the
create with
1970s,
Press
transmitting
next. Hey,
usable
how are you
science data
today?
from
Are you
outside
ready
the
to
solar
create with
system nearly
CapCut?
50 years
Hey, how are
after
you
it left the
today?
launch
Are you
pad.
ready to create with
Detecting a
CapCut?
signal this faint
Press
from this
next
far
and
away
enter an
isn't
audio
just a
prompt
matter
and
of
see how I
pointing an
sound.
antenna and
Hey,
listening
how
either.
are you today? Are you
Voyager
ready to
1's
create with
transmitter
CapCut?
has roughly
Press
the
next and
broadcasting
enter an
power of
audio
a
prompt
household
and see how I
appliance.
sound.
Yet by the time
Hey,
that
how are
signal
you
crosses
today? Are
15
you ready to
billion
create
miles
with
of empty
CapCut?
space,
Press
it
next.
arrives
Hey,
at Earth
how are you
spread
today?
so
Are
thin
you
that
ready
only
to
the
create with
largest radio
CapCut?
dishes on the
Press
planet
next.
can pick
Hey,
it out
how are
from
you today?
background
Are
noise
you
at
ready
all.
to create with
NASA
CapCut?
relies on its deep
Press next.
space
Hey,
network.
how are you
A set
today?
of
Are
giant
you ready
dish
to create with
antennas
CapCut?
spaced roughly a
Hey,
third of the
how are
way
you
around
today?
the globe
Are you
from
ready
each
to
other
create
in
with CapCut?
California, Spain,
Press
and
next and
Australia.
enter an audio prompt and
Specifically,
see how I
so that
sound.
as Earth
Hey,
rotates,
how are you
at least
today?
one
Are
dish
you
is
ready to
always
create
pointed
with
toward
CapCut?
Voyager 1's
Press
position.
next and enter an
Losing
audio
that
prompt and
constant
see how I
coverage,
sound.
even briefly,
Hey,
would mean
how are you
losing the
today?
ability
Are you
to
ready
catch
to
a
create
signal
with
this
CapCut?
week before it's gone.
Press next. Hey,
Keeping
how are you
Voyager
today?
1 functional
Are you
at
ready
all
to
has
create with
become its own
CapCut?
quiet drama
Press
over
next.
the last
Hey,
several
how are you
years,
today? Are you
one that
ready to
plays
create
out
with
far more
CapCut?
slowly and
Press next.
methodically
Hey,
than
how
any
are you
dramatic
today?
space
Are you
mission
ready to
you've
create
seen
with
in a movie.
CapCut?
In
Hey,
November
how are you today?
2017,
Are you ready to
engineers at
create with
NASA's Jet
CapCut?
Propulsion Laboratory
Press next and enter
fired
an
a set
audio
of
prompt
backup
and see how I
thrusters on
sound.
Voyager 1
Hey,
that
how are
hadn't
you
been
today?
used
Are you
since
ready
that
to create
Saturn
with
V
CapCut?
back in 1980.
Press next and enter an audio prompt and see how I sound. The spacecraft's primary thrusters how are you today? Used continuously for decades to keep its antenna pointed at Earth. How are you today? Had begun degrading with CapCut, so the team switched to a system. Hey, how are you today? Completely dormant with the Carter administration. Press next. Hey, how are you today? Are you ready to create with technical resurrection? Hey, how are you today? Are you ready to create with CapCut? Currently operating. Press next and enter an audio prompt and see how I sound. Keeping Voyager 1 alive. How are you today? Are you ready to create with CapCut? Came in November 2023. Press next and enter an audio prompt and see how I sound. Transmitting complete how are you today? Are you ready to create with telemetry? The stream of engineering and science data that tells the team on the ground whether the spacecraft is healthy. How are you today? Turned into an unreadable repeating pattern with no usable information in it at all. Are you ready to create with CapCut? Turned out to be a single corrupted chip. Are you ready to create with CapCut? Flight data. Press next and enter an onboard computer responsible for packaging data before it's transmitted home. Are you ready to create a chip failure on a computer built in the next and enter an audio prompt sitting more than 15 billion miles away? How are you today? Are you ready to create with CapCut? Is about as close to catastrophic as a mission can get without actually being catastrophic. Are you ready to create with CapCut? Engineers spent months diagnosing the audio prompt and see how I sound. The faint, garbled signal still arriving from the spacecraft. Are you ready to create with CapCut? Eventually identifying which piece of memory had failed. Are you ready to create with CapCut? Rather than replace the chip, which was obviously impossible, how are you today? Are you ready to create with CapCut? Code and relocated it to different working memory elsewhere in the computer. Hey, by April 2024, are you ready to create with CapCut? Voyager 1 was transmitting clean, audio usable science data again. Hey, how are you today? Are you ready to create with CapCut? By people solving press next and enter an audio prompt and see how I sound. Software and patience. Hey, how are you today? A crisis are you ready to create with the underlying pressure driving it never will. How are you today? Are you ready to create with CapCut? Powered by a radioisotope thermoelectric generator. Are you ready to create with CapCut? A device that produces electricity from the steady radioactive decay of plutonium rather than sunlight. Hey, how are you today? Are you ready to create with CapCut? Press next and the power source has been quietly weakening since launch. Hey, how are you today? Are you ready to create with CapCut? Electricity every year. Press next and enter an audio prompt steady decline with no way to slow it down. How are you today? Are you ready to create with CapCut? Voyager 1 launched with enough power to run 11 separate scientific instruments simultaneously. Press next. Decades of that same slow decay have already forced the team to switch off one instrument after another. Are you ready to create with CapCut? Any of them stopped working? Hey, how are you today? Because there simply wasn't enough electricity left to run them all at once. Press next and enter an audio prompt in April 2026. The team switched off Voyager 1's low energy charged particles. Press next and enter an audio prompt to conserve the dwindling power supply. Hey, how are you today? Fewer are you ready to create with CapCut? Data than press next. Hey, any other how are you today? Are you ready to create with CapCut? Even sending that single shutdown command took roughly 23 hours. Are you ready to create with CapCut? And the shutdown process itself took several more hours. Are you ready to create with CapCut? A routine engineering task turned into a day-long waiting exercise. Press next and enter an audio prompt and see how I sound. Matters because of what is still measured. Today? Are you ready to create with currently keeps a small handful of instruments and enter an audio prompt and see how I sound. Among them, its cosmic ray telescope. Today? Are you ready to create with CapCut? Plasma wave subsystem. Hey, how are you today? Are you ready to create with plasma density jump? Press next. Hey, how are you today? Are you ready to create with CapCut? NASA has described the surviving instrument. Are you ready to create with CapCut? Functioning almost like a weather station. How are you today? Are you ready to create with CapCut? Quietly logging the radiation and enter an audio prompt and see how I sound. And plasma activity of a region no other spacecraft has ever sampled directly. Press next and enter an audio prompt and see how I sound. Manager at NASA's Jet Propulsion Laboratory. Are you ready to create with CapCut? Said the team is specifically hoping to keep the plasma wave and magnetometer instruments running on both Voyager spacecraft for as long as possible. Precisely because that data can't be collected any other way. None of this happens without people who have spent nearly their entire careers on a single spacecraft. Press next and enter an audio prompt and space physicist at the University of Iowa. How are you today? Started working on the Voyager mission in 1974. Press next and enter an audio prompt and see how I sound. And is still involved with its instruments today. Are you ready to create with CapCut? 50 years later. Press next. Hey, describe the mission's arc. Are you ready to create with CapCut? What began as an exciting planetary tour turned, are you ready to create with CapCut? By accident, into an expedition representing humanity itself, with CapCut? Carried by hardware that outlived every reasonable estimate of its working life. Press next and enter multi-decade institutional memory matters enormously for a spacecraft this old. Are you ready to create with CapCut? The engineers troubleshooting an audio prompt and aeroisotope failure in 2023 needed to understand circuitry and programming conventions. Hey, how are you today? Modern engineering education doesn't cover it all anymore. Hey, how are you today? Some of the people who understood Voyager 1 best when it launched have since retired or passed away, which makes every remaining veteran on the team and every younger engineer they've managed to train up on decades and enter an audio prompt and see how I sound. A genuinely irreplaceable part of keeping the spacecraft alive. Voyager 2 isn't nearly as far along on the same road. Hey, having launched slightly earlier but taking the longer four-planet route from Jupiter, Saturn, Uranus, and Neptune, it currently trails its twin by several billion miles, sitting at roughly 19.5 light hours to Earth, compared to Voyager 1's approach toward a full 24. Both spacecraft are still moving outward, still transmitting an audio prompt and see how I sound. Now, the only two objects ever built that can report directly on conditions outside the sun's audio prompt and see how I sound. When Voyager 1 crosses the 1 light day threshold in November, Voyager 2 will be far behind on the calendar. Are you ready to create with CapCut? Even if its own light day crossing is still years away, given its slower net separation from Earth. Hey, how are you today? Are you ready to create with CapCut? The instrument shutdowns happening now aren't a new emergency. Are you ready to create with CapCut? They're the continuation of a strategy that started years ago. See how I sound. As far back as the late 2000s, engineers on both Voyager spacecraft began powering down audio prompts that had already completed their primary scientific objectives, prioritizing whichever tools still had genuinely new data to offer. Heaters keeping sensitive components at safe operating temperatures have been switched off one at a time as well, a calculated risk each time, since a colder instrument can behave unpredictably or fail outright. But the alternative is running out of power to operate anything at all. Every shutdown decision, going back nearly 2 decades now, has followed the same underlying logic. Give up something today to buy more years of the most scientifically valuable instruments tomorrow. Some researchers outside NASA have already begun sketching concepts for a dedicated future interstellar probe, one designed from the start to travel faster than either Voyager and arrive at the same kind of distance carrying modern, far more capable instruments. None of those concepts has secured full funding or a launch date yet, and any such mission would still take years of development before it even leaves the ground, let alone decades of flight time afterward. For now, Voyager 1 remains what it has been for over a decade, the only spacecraft anyone has actually flown into this environment, gathering data nothing else currently in existence can replace. No other spacecraft is currently positioned to pick up where Voyager 1 eventually leaves off in quite the same way. There's no mission on NASA's books today designed to physically fly past the heliopause and continue direct, in-place sampling of the interstellar medium the way Voyager 1 has been doing since 2012. That means whatever Voyager 1 and Voyager 2 manage to record before their power finally runs out may remain the only direct measurements of interstellar space available to scientists for a long stretch of years afterward, possibly decades, until some future mission is designed, funded, and launched with a specific goal of reaching that same boundary again. In 2020, NASA launched the Interstellar Mapping and Acceleration Probe, known as IMAP, a mission specifically designed to study the heliosphere's boundary in far greater detail than Voyager 1's aging, decades-old instruments ever could, though from a very different vantage point. IMAP sits at a stable point roughly 1 million miles from Earth, closer to the Sun, using higher resolution measurements to map the same boundary region Voyager 1 punched through in 2012. Researchers describe it as building directly on lessons from an earlier mission called IBEX, extending over a decade of heliosphere observations with sharper tools. Voyager 1 supplies the ground truth, a single direct measurement taken from inside the boundary itself, while missions like IMAP fill in the wider picture around it. The material Voyager 1 is now sampling isn't just generic interstellar space either. The Sun and its entire retinue of planets are currently drifting through a specific region called the Local Interstellar Cloud, a relatively warm, low-density patch of gas embedded within a larger cavity of even thinner material, known as the local bubble, itself carved out by ancient supernova explosions many millions of years ago. Voyager 1's direct measurements of density, temperature, and magnetic field strength are, in effect, the first ground truth samples of the exact patch of galaxy our solar system happens to be passing through right now, a region that will keep changing as the Sun continues its own slow orbit around the galactic center, carrying every planet, moon, and spacecraft along with it. Ground-based telescopes can infer some properties of nearby interstellar clouds by studying starlight passing through them from a distance. But none of that indirect work substitutes for an instrument actually sitting inside the cloud, recording its properties directly, the way Voyager 1 now does every single day. Why any of this matters beyond raw curiosity comes down to a point researchers keep returning to. The heliosphere isn't just a boundary around our solar system. It's the only example scientists have of what astronomers call an astrosphere, the protective bubble any star can generate around its own planets. If researchers ever want to understand which planets around other stars might be shielded enough from cosmic radiation to support life, the only real-world example they have to build that understanding from is the one Voyager 1 is currently sitting inside the edge of. Every detail Voyager 1 sends back about how the heliosphere behaves, how sharply its pressure boundary shifts, how strong the magnetic tension against it really is, feeds directly into models astronomers use to guess at conditions around entirely different stars, light years beyond anything a spacecraft could ever physically reach. The plasma density jump wasn't the only signature that convinced scientists Voyager 1 had truly left the heliosphere. Its cosmic ray telescope, one of the instruments still running today, recorded a sharp change right around the same time. The intensity of galactic cosmic rays, high-energy particles streaming in from elsewhere in the galaxy, shot up abruptly, while the lower-energy particles native to the Sun's own heliosphere dropped away almost as suddenly. Inside the heliosphere, the Sun's magnetic field partially shields the solar system from galactic cosmic rays, the same way Earth's own magnetic field shields the planet's surface from much of the Sun's radiation. Once Voyager 1 crossed the heliopause, that shielding effect vanished, and the spacecraft found itself sitting in a noticeably harsher radiation environment, fully exposed to the galaxy's background radiation for the first time in its journey. There's also something unmistakably human riding along with all of this data, quite literally. Bolted to Voyager 1's frame is the Golden Record, a gold-plated copper disc containing sounds and images meant to represent life and culture on Earth. Greetings recorded in 55 different languages, roughly 90 minutes of music spanning everything from Bach to Chuck Berry, and more than 100 photographs and diagrams intended to explain, to whatever might eventually find it, where and when it came from. The record's contents were curated by a committee led by astronomer Carl Sagan, who spent months debating exactly what a handful of physical objects could possibly say about an entire species to an audience that might not exist, might not find it for millions of years, or might never understand human sound and image encoding at all. Voyager 1 is moving too slowly, on too indirect a path, to ever actually reach another star system in any meaningful human time frame. And it's not aimed at one in particular. The record exists less as a functional message and more as a statement attached to the most distant thing humanity has ever built, carrying a version of who we were in 1977 outward, indefinitely, long after the spacecraft itself stops answering. And it will eventually stop answering. Nobody can say precisely when the last instrument goes dark or the last usable signal reaches Earth, because that depends on exactly how power keeps degrading and how creatively engineers keep managing what's left. The same kind of creativity that revived 37-year-old thrusters and rewrote code around a broken chip 15 billion miles from the nearest repair technician. What's certain is that every year currently squeezed out of this spacecraft is borrowed time, running on a power source that was never going to last forever, operated by a team that has made an art form out of extending forever a little further than anyone reasonably expected. Even after the last transmitter falls silent, Voyager 1 won't stop moving. It will keep drifting outward for as long as the universe allows, carrying its golden record past stars that don't yet exist, long after everyone who built it and everyone watching this video is gone. So here's what nearly 16 billion miles has actually bought us. Not a photograph of an alien world and not a single dramatic headline moment, but a working, near 50-year picture of the exact boundary where our solar system ends and the galaxy begins. A region roughly 40 times denser than expected, laced with unexpectedly strong and ordered magnetic fields, flooded with harsher cosmic radiation the moment the sun's shielding disappeared, and humming continuously with faint plasma oscillations nobody knew existed until Voyager 1 was already sitting inside them. That's what it found, piece by piece, instrument by instrument, patched together across decades by engineers willing to wait 2 full days for a single line of confirmation. And on November 18th, 2026, at 2:16 and 7 seconds in the morning Pacific time, it will keep finding it from a full light day away. The first human-made object ever to send its findings home from that particular kind of distance.